Hey there, welcome back. So, before we start today's video, I just want to quickly talk about something. So, I noticed that my last video got 10% dislike. Now, that's okay. Don't get me wrong, I'm not upset or anything like that. But I'm just curious. Because people can dislike the video if they want, but it's very useful if you don't like the video to leave a comment telling me what you didn't like. Did I say something wrong? Did I say something incorrect or inappropriate, or no, whatever. So it's very useful to give me that sort of feedback, and don't be afraid to leave a negative comment, because I can take criticism very well. So because I genuinely want to help you learn assembly language. So if there's something I'm doing wrong, then please tell me about it so I can improve future videos. So I just wanted to put that out there. Alright, but of course there were 90% likes, so that's great, so thank you everyone. I'm glad that people like my videos. Anyway, let's start today's episode. So, we are halfway there. So, when I started making these videos, I planned to make 8 videos. Now we have already gone through 4 of those videos, so we're basically halfway there now. Also, I just wanted to mention that I'm going to assume as we go along, so from video 4 to video 5 and so on, that you pretty much know the previous video, that you're fairly comfortable with what we talked about in the previous video, because I'm constantly building on what we have learned so far. So we're gonna do what we have done in all of these videos. We're gonna start with a quick repetition. So last time we talked about branching, talked a whole lot about branching. Now that's a pretty big topic. There are a lot of branches, and like I said, I don't want to make this more complicated than it needs to be. In fact, there were 2 mnemonics that I didn't even mention last time: branch on overflow clear and branch on overflow set. Now those 2 are complicated and we don't need to talk about them. I just wanted to mention it so that you at least know that they are there. And of course, as you remember, we have like this simple example. We're loading A with something. We're using compare because we need to use CMP when we're using LDA. So the accumulator has its own compare mnemonic. And if you're using LDX, we need to use CPX. LDY, we need to use CPY. So we're loading something, comparing with something, and we're branching in different ways. Branch if equal, branch if not equal, or in this case, branch if carry set. So we're branching to that label. So that's what we were talking about last time. But we also talked about loops. Now looping is actually a really interesting topic, because that's basically what a game code is. We're gonna take a look at that today actually, but understanding that everything in your game is just a huge loop running all the time, that's important. So here, if we look at this example, we start this loop by loading x with 0. I create a label called my loop, perform some code, then I say increase x by 1, compare it to 45, just a random number, 45 in this case, which is the number of times I want the loop to run. If it's not 45, then I branch up here again, and perform it all over again. And in fact, there's even we can even make an infinite loop if we want to. And that's what a game loop is. It's an infinite loop that's never going to stop. So in that case, we could just, when we got down here, instead of comparing with x and stuff like that, I didn't even have to use this LDX and on the top. I could just write my loop here, and I could have a bunch of code, and all the way at the bottom, I could just write jump to my loop. So every time we ran through all of the code here, we got down here, it says jump to my loop, and I would just go back up there again. And that would just be an infinite loop. And that's actually what game loops are. We're going to come back to that. So loops. But today we're going to look at something new. We're going to look at subroutines and macros. So a subroutine, that's a pre-written routine that can be used throughout the code. A macro is a pre-written routine that can be used throughout the code. Okay. Notice that I've used the word routine in quotation marks because it's probably not correct to call a macro a routine. But anyway, the point here is that both a subroutine and a macro, those are pre-written lines of code. We write them once, and then we use those later on, several times if you want, throughout the code. So let's start by looking at, this guy doesn't know what's going on. We're gonna have to look at this. What's the difference between these two? So let's start by looking at subroutines. Here I have a subroutine. Now, it's actually pretty simple. I just write a label, and then I write some code that I need to perform from time to time. And at the end of that code, I just write RTS. Now, RTS means return from subroutine. Then, somewhere in my code where I need to use this routine that I made, I just write JSR my subroutine. Jump to subroutine my subroutine. So we're not just jumping like we've seen before. When you jump, you just jump somewhere and that's it. Just jump to a different part of the code, that's it. Now in this case, we're jumping to a different part of the code. But since I'm not using JMP, so I'm not just jumping, this is jump to subroutine. That mnemonic expects an RTS at some point. So here I have a lot of code here, and suddenly in my code I say JSR my subroutine. That basically means that I'm jumping to wherever this my subroutine is, jumping there, then I'm performing all the code that's in there, and at some point in that code it says RTS, return from subroutine. Now when the CPU hits this point, RTS, it's going to do exactly what it says, return from subroutine. So it goes from here and it just goes back here and just continues on the next line. So we get back to where we were at this point. So we just continue on here. So this is just a temporary jump where we jump to subroutine. So we jump here, perform whatever code is in the routine. We hit this RTS, and then we just return back here and perform the next line in the code I have here. That's how subroutines work. So we have these two new mnemonics: JSR, jump to subroutine, and then RTS, return from subroutine. So we're jumping somewhere, performing that code that was in there, and when it hits the RTS, we just come back to where we were. That's how subroutines work. So let's look at an example. Here's something I made called player death. This is my player death subroutine. So the reason you would make subroutines is that let's say you have something that you're going to be using many times in your code, and you don't want to write the same thing over and over again for several reasons. First of all, writing exactly the same code in many places, that's a lot of extra work. Second of all, doing it that way, you will take up a lot of space in the code, because let's say your subroutine is 100 lines of code, then every time you wanted to perform this, whatever it was, maybe you play a death routine that was 100 lines of code. So every time you wanted to use this player death routine, you would have to write 100 lines of code. Exactly the same every time. Now that's crazy. So that's crazy because you have to do it all the time. It's crazy because it's going to take up a lot of space in your game, and it's unnecessary. You don't have to write exactly same 100 lines of code all over the place. And also, what if you wanted to change something in that subroutine, or in your player death routine? You wanted to change something in there. Well, then you would have to go all over the place searching for your player death code that you put all over the place, and it's just a nightmare. So it's not a good idea to just write the same code all over the place. So instead of doing that, we make a subroutine. So here I've made a player death subroutine. And here I just have some code, and I just want this code to run when the player dies. And I want this code to be run in different places. So for example, I have a hurt tile. When the player collides with this hurt tile, I want my player death code to run. Also, I have a player hurt script, and let's say the health was 0. Well, if the health was 0, then I want my player to die. So then I also want to run this player death routine. So instead of writing the same code in my hurt tile script and in my player hurt script, I'll just make one subroutine here called player death, where I write my player death code. I make sure to end it with RTS, so that this is a proper subroutine. And then later on, in my hurt tile script, in that script I just write JSR and the name of the subroutine. That means in my hurt tile script, when I get to here, we're gonna jump here, perform the code in here, and we hit an RTS, which is going to bring us back here, and we continue with whatever more was in that hurt tile script. Same thing for the player hurt script. There's some code up here, but then we get to JSR player death, so we just jump here, perform the code in here, we hit this RTS, and we return from subroutine. So we go back to player hurt script and go to the next line, continue on with the code there. So that's how subroutines work, and also that's why we use subroutines. We write a routine once and we just use it like this: JSR, jump to subroutine. And of course, like I said, when you define your subroutine, it must end with RTS to make sure that we can go back to where we were. So that's it's not really complicated, but if this is a new concept, then maybe you need to practice it a little bit. Now there's a problem in NESmaker. Or let's call it a challenge. It's a challenge. Because in NESmaker we have a lot of different banks. You probably heard about bank switching. There's a lot of bank switching in the NESmaker code. That's going to make this a little difficult because we haven't talked about banks. We're going to come back to that later. But it means that you can't have a routine in one bank and run it. You can't be in one bank and run a routine in another bank, for example. So there's a few challenges there. But we're going to have to come back to that. But the point right now is just trying to understand subroutines, what they are and how we can use them. Yeah. But what about macros? What are macros? Well, let's take a look at an example. Let's look at this NESmaker macro. It's called start moving. Okay, so here we have a pre-written routine. Isn't this the same that we had with the subroutine? Well, no, it's not. It's not the same. First of all, we can see that where we define this macro, we start by writing the word macro. Write the word macro, and then we write a name, whatever we want to call this macro. Now, this macro is called start moving. And we have 2 arguments here. And then we have a lot of code here. And then here at the very end, it says end macro. But there's no RTS in here. So how does this stuff work? Well, let's look at this. So in your code, if you have tried to do some stuff in NESmaker with assembly language, you probably come across this in the code. Start moving. So that command just suddenly appears in the code. But what does that mean? Well, it means that when we see start moving like this, that's the macro called start moving. And what one of the differences between a macro and a subroutine is that a macro can take arguments. So here it says arg0 and arg1. We can pass some values through there. So for example, in this case, when I'm using the macro, I write start moving, and then I use this variable player1 object. I write a comma because there are 2 arguments. We need to separate them with a comma. So write player1 object, comma, and then this constant, write. Now, understanding what this does is, it's pretty obvious. This is going to move the player1 right. But let's try to understand what's behind this. So I'm using a macro. I'm passing 2 arguments through here. So is this like a subroutine? No, it's not a subroutine. So how does this work? Well, a macro works like this. Every time you write the name of the macro, every time you use a macro like this, basically what you're doing is you're pasting all of the code for the macro in there. So that means that what we're seeing here I'm using the macro. That's actually exactly the same as this. So here we have the code for the macro, but I'm just, using player1 object and write here. But this is how macros work. So every time you use a macro like this, you have to think about it this way. Even though we can say, well, this is just 1 line of code. Well, it's actually not just 1 line of code. We can see that right here. But in actuality, it's all the content of the macro itself. It just gets pasted in there. So when we run the code, when we click export and test in NESmaker, we export all this code, and then it's run through the assembler. Now this is important because it's because of the assembler that we can use macros. So because of the assembler, we can make a macro like this, and when we run the code through there, and the assembler sees a name of a macro, and it can see that we have defined a macro with that name. So what the assembler does, it takes the contents of that macro and just puts it in there. Which means if I'm writing some code and I'm using this start moving macro 100 times, well, then we can take this code, all of this code, multiply it by 100. So we have quite a lot of code then. So that's why we have to be a little bit careful but not using macros unnecessarily. Because they actually take up a lot more space than what we can see like this. So it's a little complicated explaining macros in an easy way, but hopefully you understand how this works. You write the name of the macro, and if there are arguments, like in this case, you have to give it the arguments. But what's actually happening is that all of this code is getting pasted in instead of this when we run it through the assembler. So I hope that makes sense. And of course the difference between macro and a subroutine, like I said, is that a macro can have arguments like this. You can't do that in a subroutine. In fact, it's a little interesting here because this start moving macro, if you look at the code in here, we're even running a subroutine inside this macro, JSR O start moving in a direction. So that's no problem. We can do whatever we want because a macro is not some special thing like that. Actually, a macro is not real assembly language. Using macros is something we can do because the assembler allows us to do that. NESmaker uses an assembler called ASM6. ASM6 allows us to make macros like this. But it's not really assembly language. Of course, we need to use assembly language inside here. But start moving like this, that's not assembly language. So this can get a little confusing, but I just want to try to explain what a macro is, how we can use it, and so on. And also, it's important to understand that you're not just using one line of code like this. You're actually pasting all of the content of the macro wherever you use that, the name of the macro. So I hope that makes sense. Hope you can see the difference between a subroutine and a macro. But you know what? I think we need to get a little more hands-on. I think we need to look at NESmaker and take a look at some real code in here. I'm gonna go straight to project settings here, script settings, because now I'm just gonna briefly show you how all of these things are connected. How does NESmaker handle all of these things? Well, let's start at the top here. There's something called main ASM. If I click edit now, this is the main file for NESmaker. This is the top level file. This is the main super file, the God file. There's not a lot of code in here. In fact, it just says .include scr base. Now .include in a code like this, I haven't talked about this either, but it just means When we write .include, we can include the name of a different file in there. Let's come back to that, but this is the main file. So scr base, what's that? What kind of file is he putting in there? Well, down here there's something called base. If I click change here, you can see that it's actually called scr base. So in this main file for NESmaker, we are actually putting this file in there. So let's look at this base file. Now this is not a big file either, but there are a few more things in here. Now I'm going to try to explain this without getting too technical, so we're going to just look at this really quickly. But here at the beginning, this is some technical thing that we just need to have in there in order for to make this an NES cartridge. We have some system constants, and for every time we see include, that means put the contents of that file here in that code. So we're merging a lot of different files here in this file. Just taking this file, put that in here, take that file, put that in here. So we're merging all of these files into this base file. Memory map. Actually, you know what? Also, look at this. We're also including a file called macro list. So we're including all of the macros in here too. But let's look at this memory map. So if I go to memory map here, this file is a little interesting considering what we've been talking about, memory addresses, stuff like that. So here in the file memory map, here we can see that NESmaker is set up to use these different things at different memory addresses. So sprite RAM, for example, that starts at address 200. Collision RAM starts at address 300, object RAM at 400, and so on. So, like I said, this gets a little technical, but you know, it's probably good that you at least know about these things. Yeah, user variable RAM. So here we're including the user variables too. So this is just how everything is connected. We have this main file and we have this base file which just connects all of the other important files. And you know, you can have one file that connects another file and so on. So this can get a little complicated. But this is where all of that happens. But what I really wanted to show you was this one. Start main game loop. Main game loop. We talked about that just a minute ago. So let me go back to project settings here. If I go down to where it says game here. Here it says game. Now just below that it says main game loop. So let's look at this file main game loop. Now do you remember what I said? That this game thing, or game, that's just an infinite loop. It's a loop that's never going to end. So it's a big loop running over and over and over again. And it's going to run all the time until you power off the console. This loop's running all the time. And that's this main game loop. Now, we're not going to be looking at every single line of code in here. But what this main game loop does, let's just try to understand how this works. First of all, it starts up here, main game loop. Then we have all of this code, and then we get here down on the bottom, and look at this. It says JMP, main game loop. What does that mean? Well, that means that we are going to main game loop, we're going to jump to that label, which is up here. So we're going to perform all this code. We get down here, jump main game loop, go jump up here, and do the same thing again, and again, and again, and again, and again, infinitely. So we're going to do this forever until we power off the console. So what's inside this loop? Well, there are several things. Here, for example, there's a check for should we draw a box, draw text. So there are some checks for that, if you should draw text, for example. But look at this. Jump to subroutine. There's a jump to subroutine in this loop. What subroutine is that? Well, it's do handle input reads. So basically here in this main game loop, we run a subroutine to read the controllers, the gamepads, NES controllers. So we have a subroutine for that reads the controllers. Then we have something called screen pre-draw. Let's not go into that right now. But this one, this is a really important one. Again, we're using JSR. So we're jumping to a subroutine called do handle objects. Now, like I said, this is really important. Do handle objects. Let's go back to NESmaker to our project script settings. If I go down, all the way down here, to where it says subroutines, there's actually something here called handle objects. That's this thing that we're talking about here. So if I open this file, handle objects, inside this, and here, by the way, here's the label, do handle objects. So if we go back to the main game loop, do handle objects, jump to that subroutine. Again, we're in the main game loop now. The main game loop. Inside here, we jump to the subroutine do handle objects, which is here. Do handle objects. So what happens in here? Well, it's all sorts of things having to do with the objects. Again, we're not going to go into detail, but we're checking, is it active, is it not, is it queued to be destroyed, stuff like that. Is it queued to be activated, created? If so, then we create a new object here. We check the player against the camera position, stuff like that. And then, does this object observe input? So should this object be connected to the controllers? Stuff like that. But here, something you may have seen before, at least if you have been playing around with NESmaker. Here in our do handle objects routine, we're also running the physics script. So the physics script is important because that's the script that makes the objects move, and if it's a platform game, in there it checks if you're landing on something, all kinds of stuff having to do with the physics, gravity, whatever. So we're running that here in the do handle objects subroutine. So there's a lot of stuff going on in here. Then we continue on. We have do tile observation logic. So we're checking tile collisions. We have object collisions. Is this object colliding with another object? We're checking that in here. We do all kinds of things. Update the action timer. So how long should this object perform this specific action? So all kinds of stuff. Here we're actually drawing the sprite. And again, we're jumping to a subroutine. So you can jump to a new subroutine even though you're already in a subroutine. That doesn't matter. You can jump from a subroutine to a subroutine. And that's what we're doing here. So here we're running do draw sprites, which is the big script that's actually going to draw the sprite on the screen. So we're doing that. Yeah. And then we get down here. Now, here it says INX. Let's go up again. Let's look at something. Here inside do handle objects, when we get down here. Inside, now this gets a little complicated, so we have to sort of try to keep track of everything. But inside our do handle objects subroutine, there's a loop in here. We start that loop by loading x with 0. We've seen this before, right? So we start by loading x with 0, and then we have a label. This is a loop. This is the do handle objects loop. So all the things that I just talked about, drawing the sprite, checking the collisions, all that stuff, that happens in here. This is a loop, starting from 0. The first object, object 0, that's the player object. The first time we run through all of this code in the loop, that's for the player object. Then we get down here where it says INX. X goes up by 1. We compare x with total max objects, which I said is 13 by default in NESmaker. Has x reached 13? Well, no. And here it says branch if equal. If x has reached max total max objects, then we go to done handling objects. Then we're done. But if x has not reached 13, then we continue on. And here it says jump loop do handle objects loop. So basically, you go back to the beginning of this loop, and then we continue on doing all of that stuff for the next object. And that gets its own turn through all of these scripts, gets down to the bottom. Have we reached max number of objects? No, right? So then we go to the start of the loop here again and do it all over again for the next object. And for the next object and for the next object. So that's why when we see something like this, object whatever, object h speed high, object health whatever, object health comma x. So that's why this comma x is when let's say we're in the player hurt script or the monster script or whatever. We usually write object health comma x or whatever. So that comma x is whatever object is active in this loop right now. So hopefully you can see what I mean. Anyway, so this thing is really important. Do handle objects. This is basically that handles everything for the objects. Now let me show you something. Here I have this test game. You remember this guy right here, right? This is Codeman. In fact, his name is Cody. So this is the game Cody's Quest. So I'm just gonna run it quickly now to show you something. So I'm just gonna, this is a standard default NESmaker game. I haven't done anything to the code. Whoa, let's adjust that a little bit. Okay. So here we have Codeman. He's walking around. I mean, he can shoot. Here we have a monster. You know, pretty standard stuff, really. All right, so everything's working like we expect. The objects are moving around on the screen. The screen scrolls. They collide with each other. Yeah, you know, this is what you would expect. Let's go back to our code here. Let's go back to, let's see. Yeah, let's go back to our main game. Let's close these other ones so we don't get confused here. Let's just keep this main game loop open for now. Here we just talked about this. The main game loop. Now this is the main game loop. The one that's running all the time. That's where we're running the doHandleObject script. The one we just looked at. Where all of this stuff is happening for all the objects. Remember, in doHandleObjects, we're drawing the sprites, we're moving the sprite, we're basically handling the sprites in every way. Let's go back to our main game loop. Main game loop. Where we're running the doHandleObjects routine. What happens if I comment out that line? Putting a lot of semicolons in front of it means this is not going to run. I've basically taken this line of code out. So this is not doHandleObjects. That's not going to run now. Okay. So what happens now if I start the game? Can you guess? Try to guess what's going to happen right now. Here comes the answer. There you go. So no player, no monster, no nothing. I can't control anything because there's nothing to control. I've taken out the doHandleObjects routine. There's no routine to handle objects, which means, you know, in the doHandleObject script here, like I said, we're moving the object, we're drawing the object sprite, checking for collisions, all kinds of stuff. We're handling the object. But that code isn't running anymore. I took it out here. So we're left with this. So doHandleObjects, that's a super important part if we want to have objects in our game, which I guess most of us do. So that's doHandleObjects. But what about this one right below? JSR, jumping to a new subroutine. This time it's called doCamera. Well, you remember the first test I did. You could see that this was a scrolling game, right? Let's try to comment out this line too. By the way, this doCamera, that's the script we have down here called handleCamera or doUpdateCamera. What happens if I comment out that? If I take out that line of code, which means we're not going to be running the handleCamera script or the handleCamera routine. I've taken it out. What's going to happen now? Oh, let's see. Let's see what happens when I take out handleCamera from the game code. Right, so here must my player, I can jump and I can shoot. Okay, great. So what? Well, let's move along here. The game can't scroll because that's what the handleCamera routine does. It handles the scrolling here. So I've taken out that routine and I can't scroll because that's what the doCamera subroutine does. It handles the scrolling in my game here. And if we get down here, you can see we have a routine to handle update music and so on. So I just wanted to show you that we have these subroutines, and hopefully you can see how they work. JSR, doHandleObjects. We go here to doHandleObjects. There's a lot of stuff going on in there. but all the way at the bottom we have an RTS. So the code hits, at some point it's going to hit this RTS, which is going to bring us back here where we started that code. And we're just going to continue on the next line. And we're going to do the same thing for do update camera. So there's a lot of stuff like that going on in NESmaker. And you know, if you're new to NESmaker, then this might be a little overwhelming. But the point right now, what I'm trying to show you, is how everything is connected. And we're not just talking about subroutine like some theoretical thing. We're actually using this subroutine stuff all the time. Like here, for example. Okay. I hope that makes sense. I hope you can see how subroutines work, and maybe you also learned a little bit about what's behind the scenes here in the NESmaker code. Right, so what about macros? Let's take a look at macros. So here in NESmaker, what I usually do, because it's really convenient, I go to scripts over here, just go to input scripts, and I just click a random input script. When you do that, you get this here on the right side. This is the list of all the macros that we can use in NESmaker. For example, we have this one, start moving. We looked at that just a moment ago. Now, if you just click it, if you just click it like this, you can't see anything, because what we're seeing here, that's the random input script that I just clicked here. But for some reason in NESmaker you can view this macro, but you have to go down here and make sure the pointer changes to that, and you just drag it up like that. So now you can see the contents of that macro. In this case it was start moving. Then we have this one called stop moving. So we have a lot of different macros here. And of course these are the macro definitions. So these are written with macro and endm. And when you want to use a macro, you can just let me just go back to, let's say, start moving. What I usually do, I go in here and I copy not this word macro, but the name of the macro. Let's see if okay, so I copy the name of the macro, I copy everything, including these two comments below. So copy the name of the macro and the arguments, and if there are any comments below, I copy them too. So I just copy those, and I go to a code file, and I just paste it in there. Now the reason it's a good idea to copy the comments as well is because here it says what those different arguments are. In this case, argument 0, that's an object. Argument 1, that's a direction. So it's easier to understand that way. Okay, that's what I have for you today. Now I know that this was a super technical episode, and if you're new to assembly language and NESmaker, then this might have been overwhelming. I understand that. But I hope you got something out of this. I hope that you both understand macros and subroutines, but maybe also start to understand a little bit more about how NESmaker works, how we can use these different things, and so on. Now we're gonna take a look later on, take a look at where you can find the different things. So sort of navigate a little bit in script settings in NESmaker. But for now, that's it. Have a great day. I'll see you in the next video. Bye bye.